Engine power loss is a common automotive issue that affects vehicles of all types, from gasoline engines to hybrids. It manifests as reduced acceleration, sluggish performance, or difficulty maintaining highway speeds. At its core, this happens because the engine's ability to burn fuel properly is compromised, leading to incomplete combustion and wasted energy. Common symptoms include reduced acceleration, overall sluggish performance, and difficulty maintaining speed. You might also notice the check engine light illuminating on your dashboard. To understand power loss, consider how engines use fuel energy. Typically, only about 25 to 30% of the energy from fuel is converted into useful mechanical power for moving the vehicle. The rest is lost as heat through the exhaust and coolant, friction, or other inefficiencies. In this series, we'll explore the top 14 causes of engine power loss, from clogged air filters and faulty spark plugs to more complex issues like timing problems and turbocharger failures. Understanding these will help you diagnose and resolve power loss issues effectively. Engine performance depends on the precise air-fuel mixture. For gasoline engines, the optimal ratio is 14.71, where air and fuel combine perfectly for complete combustion. Any disruption to this balance leads to power loss and inefficient operation. The engine operates through a four-stroke cycle. Intake draws in air-fuel mixture, compression squeezes it, power stroke ignites for force, and exhaust removes waste. Problems in any stroke, like poor ignition or restricted flow, cause power reduction and misfires. A clogged air filter restricts airflow to the engine, starving it of the oxygen needed for proper combustion. This imbalance in the air-fuel mixture reduces the engine's efficiency and leads to noticeable power loss. Faulty spark plugs fail to ignite the air-fuel mixture properly, causing misfires. This leads to incomplete combustion, wasted fuel, and a noticeable drop in engine power. Both a clogged air filter and faulty spark plugs disrupt the engine's combustion cycle, where air and fuel must mix and ignite properly to produce power. Replacing these components often restores lost performance. A bad fuel filter restricts fuel flow to the engine, leading to fuel starvation and reduced power output. Symptoms of a clogged fuel filter include rough idling, unexpected engine stalling, and difficulty starting the vehicle. A failing fuel pump can't provide adequate fuel pressure, disrupting proper combustion and causing power loss. Both issues share symptoms like rough idling and stalling. Replacement of the filter or pump is typically required to restore proper fuel delivery. The oxygen sensor, located in the exhaust system, measures the amount of oxygen in exhaust gases after combustion. This data is crucial for the ECU to adjust fuel injection and maintain the optimal air-fuel ratio. When the oxygen sensor fails, it sends incorrect readings to the ECU, leading to improper fuel adjustments. This disrupts the air-fuel mixture, causing inefficient combustion and a noticeable loss in engine power. The air-fuel ratio is critical for combustion efficiency. Too lean means excess air, too rich means excess fuel. An incorrect ratio from a bad oxygen sensor results in incomplete burning and reduced power output. The mass airflow sensor, located in the intake system, measures the volume and density of incoming air. This information is essential for the ECU to determine how much fuel to inject for the proper air-fuel ratio. A faulty MAF sensor provides inaccurate airflow measurements, causing the engine to run too lean with too much air or too rich with too much fuel. Faulty oxygen and MAF sensors cause the air-fuel mixture to be out of balance, leading to inefficient combustion. This results in misfires, reduced power, and symptoms like rough idle or hesitation during acceleration. The engine struggles to maintain optimal performance. Diagnosing sensor issues requires an OBD2 scanner to read error codes from the ECU. Symptoms include illuminated check engine light, reduced fuel economy, rough idle, or black exhaust smoke. Regular sensor checks and maintenance help prevent power loss. Replacing failed sensors restores proper engine function. A clogged exhaust system or catalytic converter creates back pressure that restricts exhaust flow and reduces engine power output. Vacuum leaks allow unmetered air into the intake system, throwing off the air-fuel mixture and leading to rough idling or hesitation. Proper diagnosis and repair of exhaust restrictions or vacuum leaks restores smooth operation and maximizes engine power. Timing belt or chain problems occur when the belt or chain stretches or wears, causing misalignment between valves and pistons. This disrupts the engine's timing, leading to power loss or even preventing the engine from starting. The comparison shows how an elongated chain differs from a normal one, with the stretched chain failing to maintain proper tension. EGR valve malfunctions happen when the valve allows too much exhaust gas back into the intake, clogging the system with carbon buildup and throwing off the air-fuel mixture. This imbalanced combustion reduces power and efficiency. The diagrams show the EGR system flow and a clogged component, highlighting how buildup restricts proper recirculation. A weak battery or failing alternator can affect ignition and fuel systems, resulting in power loss. Piston ring wear leads to compression loss, reducing engine power. Overheating warps engine components, reducing efficiency and power. Turbocharger or supercharger failure reduces forced induction, causing power loss in boosted engines. Regular maintenance is critical to prevent these issues and maintain engine power.